Hello lads, so we're going to have a look today at different types of tangents and the relationships to chords, or relationships to circles. So we're going to start with a simple one, probably the most simple one. So the first one we're going to have a look at is the single tangent. Okay, so we're going to have a look at the strategies that can be involved here. So sometimes the question is going to be asked to get information about the circle from the tangent, and sometimes the question is going to be asked to find information about the tangent using the circle. So listen, I'll show you one of them and see how you feel. So here's a circle. Now you can see it's in an expanded general form, okay? So it could be an x squared minus h, y minus k is equal to r squared form, or it could be just a simple circle as an x squared plus y squared is equal to r squared, but this case it's the expanded form, okay? So I'm going to give you a point here, and I want to find the equation of this tangent. So let's think about it for a second. In order to find the equation of a line, which a tangent is, you need a point on the line, and I do, and you need the slope. Now I can't find the slope just from that one point. However, knowing the fact that if I draw a line from the center to that point of contact between the tangent and the circle, it's perpendicular. I can, if I know this coordinate, find the slope of this line and then find its perpendicular companion and use that. So I need to find the center of this. So to find the center of this, we look at the x coefficient and we divide it by 2 and change the sign. So it becomes 2. And we look at this and we divide it by 2 and change the sign. It becomes minus 1. Okay, so that is how you can read off very quickly the center of a circle when it's in this expanded general form. Okay, so now that I have this, I'm going to find the slope of this. So I have 2 and minus 1, and I have 5 and minus 5. So that's x1, y1, x2, y2, and it's y2 minus y1 over x2 minus x1. So that's minus 5 plus 1 is minus 4 over 5 minus 3, which is 2. So it's minus 2, which means the perpendicular slope I'm actually looking for is a half. Okay, so now that I have actually, 5, that's not a 3, it's a 2, sorry, that's 3 is 3 minus 4 over 3. So sorry, the perpendicular slope is actually 3/4. Don't know why I got that wrong. So sorry, got that wrong. Minus 5 plus 1 is minus 4. 5 minus 2 is 3. Minus 4 over 3 is one slope, so the other slope has to be 3/4. So now that I have that, I can use it with the point. So 5 and minus 5 and 3 over 4. So y minus y1 is equal to slope on x minus x1. So multiplied left side by 4, 4y plus 20 is equal to 3x minus 15. Okay, so let's just put this all together. That's going to be 3x minus 4y minus 35. And there you have. Okay, so now let's move this on to a harder version. Okay, what happens if you have two tangents parallel to each other? Okay, how do I find the two possible tangents? So again, in order to do this, you're going to need some information about the tangent. You might be told the slope of the tangents, you might be told the general formula, or you might be told, and here's an example, here's a third line, this line's a chord, and this chord has a formula of 3x plus 4y minus 6. And it's parallel to these two tangents, which means both these tangents have 3x plus 4y plus c. And this one might be just 3x plus 4y plus k. And I want to find the two possible values for c and k. Okay, so how am I going to do it? Well, I'm going to need some information. Okay, let's say that this is a circle of this form. Well, that means that the distance from there to there is the radius, and the same distance from there to there is the radius, and the radius of this is 5, and the center of this is 0, 0. So now if you look at it carefully, I have the perpendicular distance from there to there from either of these lines. So I can use the perpendicular distance formula to solve for the c value. So let's have a look at that. So perpendicular distance formula, we already know, is ax1 plus by1 plus c over the square root of a squared plus b squared. So let's pop this all in. A is 3, b is 4, c is c. x1 is 0, y1 is 0. And we're solving for this. So let's pop everything else in. 3, absolute value, 3 times 0, plus 4 times 0, and the distance is equal to 5, which is the radius, plus c, all over the square root of 3 squared plus 4 squared equals 5. 3 squared plus 4 squared is 25. The root of 25 is 5. 5 times 5 is 25. So we've got the absolute value of c is equal to 25. So c could be 25, or c could be minus 25. So the two possible equations I'm looking at are 3x plus 4y plus 25, or 3x plus 4y minus 25. Now, let's have a look at the third scenario with tangents. What happens and this is probably the weirdest one, apologies for the world's worst circle. What happens if you have tangents that do this? They meet somewhere at a point. Okay, so how do we deal with tangents that meet at a point? So first of all, we have to kind of think about it for a second. Okay, so I'm going to put a scenario to you. Here we have another circle. Let's call it x squared plus y squared is equal to, we'll go easy, well, we'll go a little bit harder on this one. You get bored sometimes. It's equal to 5. Okay, and then let's take an external point here. Okay, so let's put in the information we know for starters. First of all, I can draw a perpendicular line where it touches, and each of those distances is root 5. Okay, so I'm guaranteed that each of those distances is root 5. Apologize for that. I don't know if I have a rubber to rub that out. Probably don't. Need to probably invest in one. No, I don't. Okay, so you can see what I'm doing here. And actually, if you want to go even further, if I draw a line from the center to there, I've got a right angle triangle. So I could find the distance from there to there by just getting the distance from there to there and the distance from there to there and using Pythagoras. But that's a whole other ball game. Okay, so let's have a look at my strategies here. In the previous question, if I wanted to find the equation of this, all I'd need to use is the perpendicular distance formula, because I'd have all the information. I have a 0, 0, I have the distance, and I would just be missing a part of the ax plus by plus c. I'd be missing the a, b, or the c, and I could just solve for it. Now, of course, in this case, I don't have any of that, but I can still generate something. So let's generate. All I know about these two lines is they contain 5 and 0. So let's assume I knew what I was talking about. And what would be my slope? Let's just call it m. I pop in y minus y1 is equal to m on x minus x1. Okay? So y minus 0 is equal to m on x minus 5. Y is equal to mx minus 5. So you'd have mx minus y minus 5 equal to 0. So there is, sorry, minus 5m. Sorry. So there you have an equation. Now it's missing a lot of things, as you can see, but it's not missing too much. So let's slot this now into our perpendicular distance formula and see what happens. Because what we're looking for is, will it generate two possible m's that then I can use, one for the top and one for the bottom. So let's see what happens when I pop this in. So remember, for a perpendicular distance formula, we need an a, a b, a c. We need an x1, we need a y1, and we need a distance. So our distance is root 5. Our x1 and y1 are 0 and 0. A is going to be the number in front of the x, which is m. B is the number in front of the y, which is minus 1. And C is the constant, which is minus 5m. So as you can see, I have only one letter missing, which means I can solve for that letter. So let's have a look what happens when we pop it all into our formula. A times x1, m times 0, plus b times y1, minus 1 times 0, plus c, all over the square root of a squared plus b squared, and that's equal to the square root of 5. Okay, so you can see where this is going. Let's tidy up the top line. They're all zeros, and that's just minus 5. So the absolute value of minus 5m over the square root of m squared plus 1 is equal to root 5. Okay, so you can see where this is going to go now. So I'm going to use another sheet of paper. It's going to extend this up so you can see what's going to happen next. We're going to cross multiply these two. So we have the absolute value of minus 5m, is equal to, we're going to multiply these two together, the square root of 5 times m squared plus 1. So how do we get rid of this? We're going to square both sides. Squaring this side gives me 25m squared. Squaring this side gives me, and multiplying out the bracket, gives me 5m squared plus 5. Let's bring everything together. That's 20m squared minus 5 is equal to 0. So let's solve this. You can use the minus b, or you can just factorize 5. 5 times 4m squared minus 1 is equal to 0. So let's see, what are we going to get here? Will this work? You're going to get 0, and you're going to get m squared is equal to a quarter. Let's see, 4m squared minus 1 is equal to 0. 4m squared is equal to 1. M squared is equal to a quarter. Now, that means that m is equal to, well, what's the square root of a quarter? Square root of a quarter is a half or minus a half, because both of those will square to give you a quarter. So there's my two possible slopes. Okay, so you can see that now. I have two possible slopes with one possible point. So now I have to create my two equations. So now, here we go. If m is equal to a half, and I'm using 5 and 0, or m is equal to minus a half, and I'm using 5 and 0. So y minus y1 is equal to m on x minus x1, or y minus y1 is equal to m on x minus x1. So y is equal to a half x minus 5 over 2, or y is equal to minus a half x plus 5 over 2. Multiply both sides by 2, so you're going to get 2y is equal to x minus 5, or 2y is equal to minus x plus 5, and then rearrange x minus 2y minus 5 is equal to 0, or x plus 2y minus 5 is equal to 0. Wow, bit epic, that one. Slightly bit epic. So that's that one done. So that's one possibility. Right, so the last scenario. the last scenario that can come up. And this one is a kind of a, it's not that it's any harder, it's just a kind of an addendum to the other ones. What happens if you have this scenario? Sorry. So you have a line from the center to a point, and a line from the point to there. Okay, so let's see what type of information we've got. Let's say we put that as -5 and 8, and I'm just going to give you this: x squared plus y squared minus 4x minus 6y plus 3. And I want to find the length from A to B. That's all I want. Okay, so first thing I'm going to do is I'm going to complete this and show this is a right angle triangle. So that squared plus that squared is equal to that squared. Simple as that. So let's find this point here. X squared plus y squared. So this point is going to be half that number and change the sign. Half that number and change the sign. So now I have this point here, and I have that point there. So let's find the distance from there to there. -5 and 8 to 2 and 3. x1, y1, x2, y2, square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. That's 7 squared, which is 49, plus 25 is root 74. So this is root 74 of a length. Let's find the length of this one here. It's the radius of the circle. The radius of the circle, when you've got it in this form, is the square root of g squared plus f squared minus c. So that's the square root of 2 squared plus 3 squared minus 3. So that's 4 plus 9 is 13, minus 3 is root 10. So that's root 10. So Pythagoras says that AB squared should be equal, plus root 10 squared should be equal to root 74 squared. So that means that AB squared is equal to 10 minus 10 plus 74. Okay, which is 64. Which means that the length of AB is the square root of 64, which is 8. It's not -8 because we're dealing with distance, it's +8. So there you go.